Yeah. So how did you proceed?
Ma'am, so there were some rules of logarithms that we used.
Yeah.
So
So what should be the first step here?
the first step is to, because the base is raised to 1 by 5,
Yeah.
there is a rule where that is equal to m by n. So it is 1 by 5. So basically it becomes 5.
Okay. So the first thing is we can take the 1 as 5x power 0, right? And this is the power of 5x. That means we can equate this log 5x power 1 by 5 into this polynomial equals to 0. Right? Right?
Yes, ma'am.
Yeah. Then log of something is 0 means this something is equals to 1. Right? That means this 6x cube minus 36x square plus 66x minus 35 power 1 by 5 will be equals to 1, right? Then
Yes.
we have a cubic equation and we can solve it, right? So what are the roots of this equation? Equals 1. So what are the roots of this equation? You just solve it and let me know what are the roots. First we can take 6 as common, right? So we will get x cube minus 6x square plus 11 6 minus 6 equals 0, right? Now we can simplify this, and what are the roots of this equation? Anyone? What are the roots? You're solving it, right? Am I audible? You can hear me, right?
Yes, yes, ma'am.
Yeah. So you are solving this, right? So what are the roots? If I take this equation equals 0, then what are the roots? So we took log 5x both side, log 5x 1, then this cancelled out and it's become log of this equals to 1. Then I took this equals to 0. So from this we get log of 5x plus 1 by 5 power 1 by 5. This equals to 0, right? Then what we did, then we can take, what can we do after that? What should be the next line? Anyone?
Ma'am, so your equation is log 5x raised to, that's your equation, right? That is equated to
Yeah.
0. Okay.
Yes, the whole equation, like from log to the whole equation is 0. That means what can I do in the next line?
Can you bring 1 by 5 down?
Yeah, we can do this thing, and 1 by 5, 1 by 5 will be cancel out. But the thing is, this is our base, okay? And
Yes.
this is something we're applying to the log, and the value we are getting is 0. And we know that logarithmic function is 1, 1, right? And only log of something at base, the base, forgot the base for now, but log of 1 is equals to 0. We know that, right?
Okay, so this will be equal to 1 then
Yeah.
the 6.
Yes.
Okay.
Correct. Very good. 35 will be equals to 1, right? Then if I simplify it, then we will get x cube minus 6x square plus 11x minus 6 equals 0. Now we have to solve this equation and we have to calculate the value of x. So what will be the root of this equation?
I think it's x minus 1, x minus 2, and x minus 3.
Sorry for the noise. It's x minus 1, x minus 2, and x minus 3. Okay. So we can express this as x cube minus x square minus 5x square plus 5x plus 6x minus 6, right? Equals 0. This equation we can express in this form, right? Then x square we can take common. We will get x minus 1 minus 5x we can take as common. Again we will get x minus 1 plus 6 common. Then x minus 1 equals 0, right? Then x minus 1 into x square minus 5x plus 6 equals 0. And this will give us the x minus 2 and x minus 3. So yeah, you are right. So we have x equals to 1, 2, and 3, right? So we got basically 3 values of x, right? So
Yes.
yeah, x equals to 1, 2, and 3. Now let us check the answer. What is the answer? So the answer is 3, right? That means for x equals to 1, 2, and 3, we can see that this 3x will satisfy this equation. Okay, so the number of solution is 3. Any doubt? Any doubt?
No, ma'am.
No, ma'am.
So what about this one? This is easy. Let me take something else. What about this one? You solved it? If not, then I will solve it. You can tell me, no problem. If you have tried it, then it's fine. If not, then we will solve it together. You have tried it or not?
Yes, ma'am.
Okay. So, shall I do it or can I skip it?
Ma'am, please do it.
Okay.
Yes, ma'am, please do it.
Okay. Okay. So we have this log base at root 2 x plus 4. So we can write it as 2 log 2 x plus 4, right? This term minus log 2 half x plus 2 equals 1. So this equation we can rewrite in this form. Do you know why? What is the reason? Why can I write it in this form? How can I write it?
Because of the that rule where m by n, you can bring it forward.
Yeah, correct. So we have, very good. So we have log root 2x plus 4. We can write it as 1 over log x plus 4 root 2, right? Then in the next step, we can take this root 2, that means power half, as 1 by 2 log x plus 4 2, right? So this will be 2 by log x plus 4 2, and in the next line we can write it as 2 into log 2 x plus 4. Clear? Okay.
Yes,
So
ma'am.
yeah, then we can take this 2 over here, so we will get log 2 x plus 4 square, and minus log 2 this, that means we can use the division rule, right? So it will be half x plus 2 equals 1, right?
Yes, ma'am.
Yeah. So then log 2 x plus 4 square, and this will be x plus 4 by 2, that means we can take this 2 over here, equals to 1. Now if I take 2 here and 2 here, then this term will be 1, and we will get 2 into x plus 4 square by x plus 4 equals 2, right? And this 2 will be cancel out. X plus 4 will be not cancel out. So we can then rewrite it as x plus 4 whole square equals x plus 4, right? We are just multiplying this over here. Then we can take x plus 4 as common, and we will get x plus 4 minus 1 equals to 0. That means x plus 4 and x plus 3 equals 0. That means we will get the value, the root, as minus 3 or minus 4, right? But if I take x equals to minus 4, then if I put it here, then we will get log root 2 of 0. But we know that log of 0 is not defined, right? So we will discard this root and we will just take the root minus 3. Okay? Then the first answer will be the correct one. Any doubt?
Yeah, ma'am. Ma'am,
Yeah.
right hand side 2 कहाँ से आया?
Okay. So we are taking like 2 power this, like 2 power left hand side equals to 2 power right hand side.
Okay.
Okay. So 2 power left hand side when we are taking, then 2 log 2 will be 1, right? And this 2 power 1 will be 2, right? That is what is written here. Is it fine now?
Okay, ma'am.
Any other doubt? Any other doubt? Okay. So if you don't have any doubt, we can move to the next question. What about this question? What about this question? Let us do it one by one. So what about the first option? Whether it will be 1, 1 or not? If 1, 1, then what is the justification? Any one of you, just you can unmute yourself and let me know. What about the first option? Anyone? It is true or false? Okay, so the thing is, we have a result. Composition of two 1, 1 function is a 1, 1 function. Okay, here we have given that f is a 1 1 function, and we know that logarithmic function is already a 1 1 function. Hence the composition function will be 1 1 function. So this is correct. Okay. This statement we can prove. So let us go to my note to prove this. So we have, if we have 14 factorial to the power 14 is less than 15 factorial to the power 1 over 15. 1 over 14 is less than 15 factorial 1 over 15. Okay, so this is what is given. So it will be true if and only if we can take log 14 both sides, right? So if I take log 14 factorial, then we have 14 factorial 1 over 14 will be less than log 14 factorial 15 factorial 1 over 15. Okay, any doubt? Is it fine up to now?
Ma'am, so you're just taking log 14 factorial on both sides.
Yeah. I'm just taking log 14 factorial on both sides. Then in the next line, I will get 1 over 14 log 14 factorial less than 1 over 15 log 14 factorial 15 factorial. Okay. Then this will be equals to 1, right? So we will get 1 over 14 less than 1 over 15 log 14 factorial 15 factorial. Again we can write it as 15 into 14 factorial, right? Then we can take this 15 here, so we will get 15 over 14 is less than log, then apply the multiplication rule. So log 15 plus log 14 factorial. Okay, again this term will be equals to 1, right? Then 15 by 14, this 1 we can take here, minus 1. This will be less than log 14 factorial 15, right? Then this is minus 14 less than log 14 factorial 15. Okay. 1 less than log 14 factorial. This 14 we can write here, then 15. Okay. Any
Yeah.
doubt up to now? Yeah. Any doubt?
No.
Okay.
No, ma'am.
Okay. So in the next line, we can write it as log. This 1 can be written as log 14 factorial of 14 factorial less than this 14. Again, we can take here. So we will get log 14 factorial 15 power 14, right? Then we can take this log 14 factorial from both sides. Then we will get 14 factorial is less than 15 power 14, right? So this is true, right? 14 factorial means 1 into 2 into 3 into up to 14. So it will be obviously less than 15 into 15 into 14 times 15, right? So
Yes.
this equation is true if and only if the first line is true, right? And we know that this equation is true. That means the first line, the first inequality is true, right? That means our option 2 will be true. Okay, any doubt? Any doubt?
No, ma'am.
No.
Okay, so in option 3, we are adding all the 1 1 functions, right? That means 2 power x, 3 power x, up to 100 power x, all are exponential function, and individually all are 1 function, right? And we are adding 1 function, so the addition will be also 1. Okay. And what about the fourth option? Any idea? Any idea? You can try it. It may be wrong, it may be right, doesn't matter. Just try it at least. What is coming to your mind? What should be the fourth option? Logarithmic function, we know that if x is tending to infinity, then log x is tending to infinity, right? That means we can take a value of fx such that log x is greater or equals to 100, right? If I take fx equals to some constant c such that log of c is greater or equals to 100. So we can take this constant function c, right? Because there are some x for which the logarithmic of this x will be greater or equals to 100, because log is tending to infinity. When x is tending to infinity, that means there are so many real numbers for which we will get the image as greater or equals to 100. So we can take that constant function as fx, right? And if I put this in, we will definitely get log of fx is greater or equals to 100, right? Any doubt? Yeah. Yes. Any doubt? No.
No.
Okay. What about the fifth one? How can we solve the fifth question? So the first option we know from the result. What about the second option? If this is a rational number, we know that rational numbers are in the form p by q, right? That means log 5 of this number will be in this form p by q, where p and q are from integer and q is not equal to 0, right? Then again we can take 5 here, like 5 power the whole logarithmic and 5 power p by q. Then this will be 1. So we will get this number is equals to 5 power p by q. That will imply this number power q is equals to 5 power p, right? That means 5 should divide this number, right? It will imply 5 should divide this number, right? This number star, suppose. But we can see that the number is ending with 9, right? So the one number which is ending with 9, is it possible for 5 to divide the number?
No. No, ma'am.
No, right? So we are getting a contradiction from here. That means this option is a incorrect one. Okay. Okay. For the third option, we will again use the result that composition of two 1 function is 1 function. So we know that logarithmic function is 1. We will check whether the quadratic function is 1 or not over the interval. So can you check it? Is it 1 or not in this interval?
So, because for the plus one, it's also one. Sorry,
We have
for
to check it in this interval. Okay.
Okay.
Yeah, the first thing is it will be parabola in a upward direction or downward direction,
Upward direction.
right? And what is the vertex?
Vertex will be 1
minus b
and
by 2a.
sorry, yes, minus b by 2a, minus 1 by
That means minus
minus 1,
0.5,
minus 1 by 2, minus 0.5.
right? That
Yes,
means from this in this interval, they're asking about this interval. So we are taking only this part of the parabola, right?
the right side of the parabola.
Yeah, to interval. That means in this interval, our parabola is 1, 1, right? And in this interval, logarithmic function is also 1, 1. And we are taking the
Yes,
composition of two 1, 1 function in this interval. And we know
so it
that
will be also
1, 1,
1
right?
1.
Yeah.
Yes.
That means this option is a correct one. Okay.
Mm.
Any doubt?
No.
Okay. Next. What about the fourth one? We have to calculate the point of intersection of both the functions. So we know if I want to calculate the point of intersection of some function, then we have to equate it, right? That means,
Right.
yeah, 5 power 3t minus 2 will be equals to 3 power 2t plus 1. And from here, we have to basically solve.
Take the log.
Yeah. So we will take ln, okay? Ln both side. That means log based at e, right? Then we can take this 3t minus 2 ln 5 equals 2t plus 1 ln 3, right? Then 3t ln 5 minus 2t ln 3 will be equals to ln 3 plus 2 ln 5, right? Then we can take the t as common. So we will get 3 ln 5 minus 2
ln 3 plus 2.
yeah into t is equals to ln 3 plus 2 into ln 5, right? Then our t will be equals to ln 3 plus 2 ln 5 by 3 ln 5 minus 2 ln 3, right?
The first option is correct.
Yeah. Okay. So we can again rewrite this equation in some other form. So we have to check whether another option can be correct or not. Okay. Okay.
Second option seems to correct. Second or third option.
Okay. So we can check it, right? So this can be also written as ln 3
plus
plus
5
ln
square.
5 square. That means ln 25, right?
Right.
By ln 5 cube means 125 minus ln 3 square means 9, right? So from here we will get 25 into 3 means 75, right? So ln, yeah, ln 75, then ln 125 by 9, right?
Second option.
And the third option is also correct, right? This can be written as ln 125 by 9 into 75. Change of base rule, right?
Oh, yes.
Okay, so the all first three options are correct.
Correct.
Yeah. Any doubt?
No. Yeah. No.
Okay. What about this one? Log 2 is a rational number. We can check it via the same rule. So you just try to check it and let me know whether it is coming or not. If it is rational, you have to take it as p by q, right? Then we can take 5 power both the side, then we can conclude. So what is the conclusion?
So it's a, log, it's a base of 5 and 2. In the similar fashion, the way we have, seen that if number is not multiple or, last digit is not divisible by 2, then it's
Yeah.
irrational. So probably it's an irrational number.
Yeah, correct, correct. So that is the logic. That means if I take this as p by q, if it is, suppose it is rational, then it will be in this form p by q. Now we can take again 5 both side. So we will get 2 equals 5 power p by q, right? Then it will imply 2 power q equals 5 power p. That means 2 should divide 5 or 5 should divide 2, but this is not possible, right? Hence, this is incorrect. What about the second one? We know that, like, if b is from 0 to 1 and if the base is from 0 to 1, then the logarithmic function is a decreasing function, and if the base is greater than 1, then the logarithmic function is increasing function. So this is a hint. I just try to solve it using this hint and let me know whether this option is correct or not. I'm waiting for some time. You just think about it. So using the increasing and decreasing thing, you have to conclude. Use the definition we know for increasing and decreasing function, right? You just have to use the definition of increasing and decreasing function. This is the hint. Take 2-3 minutes and try to conclude something. Any justification? No? You can try it at least. Just think about the definition of a decreasing function. This is the hint. You just have to apply the definition of decreasing function. When b is 0 to 1, logarithmic function is decreasing, and you have to apply the definition over x. Any justification? No? Okay, so what we know, like if a function is decreasing, then what is the definition? If x is greater than x2, then f of x1 is less than f of x2, right? Right? The reverse inequality if a function is decreasing, right? Right?
Yes, ma'am.
Yeah. So we have the function is decreasing in this, for this b, and 0 x is less than 1. That means it will reverse the inequality. That means if I take log b both side, log b x will be greater than log b of 1, and log b of 1 is 0, right? That means log bx will be greater than 0, and here we have less than 0. That means this option is incorrect. Is it fine? Is it fine?
Yeah, looks fine.
Yeah, ma'am.
Okay. So similarly, for the last two options, again the function is decreasing. Okay. And we have x is less than 1 and x is greater than b. If x is greater than b, then log bx should be less than log b. That means 1. So this is incorrect, right? This is incorrect. And x is less than y means log bx should be greater than log by. Here we are just applying the definition of decreasing function, right? Hence this option is correct. Any doubt?
No.
Any doubt?
No, ma'am.
Now we have only the third option. So let us check. So we have log 3 of log 5x equals 1, right? We want to cancel the log. So we can take 3 over here, both sides. So this will be 1. Then we will get log 5x equals to 3, right? Then again we can 5 over here. So this will be again 1 and we will get x equals to 5 cube. That means 125, right? So this option is a correct option. Okay.
Yeah.
Any doubt?
No.
Okay. The second one. Okay. So Jaws deposits 5 lakh in a bank that compounded quarterly at a rate of 20% per year. How long it will take it to increase his money to 16 times of the principal amount? So we know that the final amount A is equals to principal amount 1 plus rate by the number of repeating in a year n into 100 to the power nt. This is the thing, right? And they ask how long it will take. That means the value of t when the final amount is 16 times of the principal amount. That means when a is equals to 16p. Okay. So a is equals to p. 1 plus r is 20. Quarterly a year means n is 4 into 100. 4t. Okay. This is what we have. Now we can cancel them out from the both sides, right? 16 means what? 2 power 4, right? Right?
Yes, to the power 4 and 4 to the power 2 also.
So 2 power 4 we will take because here we have 4. We can cancel it out, right?
Okay, got it.
Yeah. Okay. Then we have 40 plus 2. So 1 over 2 will be cancelled out. Then 1 over 20. Then t whole power 4. Okay. Then 21 by 20 whole power t is equals to 2, right? Then we can take log both sides. So we will get t ln 21 by 20 equals to ln 2, right? Then t will be equals to ln 2 by ln 21 by 20. That means this option is a correct option. Okay.
Yes.
And the next option is also correct, right? By the change of base formula. Right? Okay. This option also we can write it as 16. 16 is 2 power 4, right? And this is 2 power 4 and this 4 we can take here. So there will be 4 and this 4 will be cancel out. And then this will be again same to this value, right? So this option is also correct one. Okay, so these three options are correct. Okay, any doubt? Any doubt?
No, it's clear.
Ma'am, I have a doubt.
Yeah.
Ma'am, how this formula came?
Which one?
Ma'am, A is equals to P1 plus R.
This one?
Yes, ma'am.
Yeah, this is a standard formula. This is a standard formula from arithmetic. You have to remember these formulas. Okay.
This is the formula
Okay,
of
ma'am.
compound interest to
Yeah.
find the,
Formula for compound interest and simple interest. These are the formulas you have
right,
to.
right.
Yeah.
Okay, ma'am. Thank you.
Okay. Yeah. Any other doubt?
No, ma'am.
Okay. Yeah. What about the first one? Tried it? So basically, we have to solve the equation, right? How can we solve it? Anyone? Any idea? At least, how can we proceed? Try to use change of basis and other formulas that we know. Any idea? How can we proceed at least?
Log x b to the power 4, log b3 x b to the power 9, something like
That means change of basis you are trying to apply, right?
that. Right.
Yeah. So we can write it as 4 1 over log bx plus 9 log b power 5 6 equals 1, right? Now the base is same. So here we can apply the multiplication formula. So we will get 4 log bx plus 9 right? We are applying the multiplication rule here. Okay, this quantity will be 1, right? And this 5 we can take here. Okay, so what will be the next step? Plus 9 5 plus log bx equals 1. Is it fine up to now?
Yes.
Okay. Then for simplicity, we can take the log bx equals to some number, suppose k. Okay, suppose k equals log bx for simplicity only. Okay, then we have 4 over k plus 9 over 5 plus k equals 1. Okay, then we will cross multiply them. So 20 plus 4k plus 9k is equals to k into 5 plus k, right? That means 20 plus 13k is equals to 5k plus k square, right? So we will get a quadratic equation, k square minus 8k, right? Minus 20 equals to 0. This is the quadratic equation, right?
Right.
Yeah. So what are the root of this equation? Calculate and let me know what are the roots of this equation.
10 minus 10k minus 2, sorry, plus 2k. So 2k equal to 2, 8 plus minus. Okay.
Right?
Okay.
Then what we will get? What we will get?
144
It's
plus minus 12. 8 plus minus 12 by 2.
10 minus 2.
this, right?
Yes.
So once we will have 10 and minus 2. Yeah. So 10 and minus 2 are
10
the
and minus
roots. And that means k equals to 10 or minus 2. That means we have log bx equals to 10 or log bx equals to minus 2, right? From here, we can calculate the value of x. So from here, what will be the value of x?
The value of x will be
We can take b here and here. This will be 1, right?
x equal to b to the power 10 or b to the power half.
Yeah. b to the power minus 2.
Yes, minus not half.
B to the power x
10.
equals to b to the power minus 2, right? So these two are the values. That means this and this option are correct option.
Correct.
Yeah. Any doubt?
No, ma'am.
Okay. So I solved most of the problems from practice assignment. So do you have any other doubt in practice assignment?
No.
No, ma'am.
No? Okay. So we can move to activity questions. So yeah, let us start from 6.1. So anything in 6.1? You can share, see the screen, right?
Yes, yes, it's very visible.
Okay. Yeah. Anything is 6.1?
I have not tried. I have just completed till week 5. So today I will be completing the 6
Okay.
and 7. So that is the reason, not able to actively participate the way you want.
Okay, okay. And what about others? Okay, I will pick some problems then randomly. Okay, we can try to solve the third question, right? So what about the third question? Domain. In the summary session, I discussed, right, how to calculate the domain of in log of any function. If I have, then how to calculate the domain, right? So what should be the first step? Some of you were present in the summary session, right? Right. Who was present in the summary session? Anyone? No one was present in the summary session? Okay. Okay, I will repeat. So the thing is, we know that the domain of logarithmic function is 0 to infinity, right? Here we have log of some function, but we know that if I want to define the last log, we need this portion to be greater than 0. Okay, so we will start with log 10x square minus 8 log 10x plus 15 as greater than 0. Okay, we can take this log 10x as p for simplicity. So we will get p squared minus 8p plus 15 is greater than 0. Okay, so we can factorize this equation, right? How can we factorize this equation? You just try to factorize and let me know what is the factorization of this equation.
3 and 5.
3 and 5, yeah.
Correct. So p minus 3 into p minus 5 greater than 0, right? Yeah. So here we have like multiplication of two numbers is greater than 0. That means either both the number are positive or both the number are negative, right? That means p minus 3 greater than 0, p minus 5 greater than 0, or p minus 3 less than 0 and p minus 5 less than 0, right? So here we will get p greater than 3, p greater than 5. Here we will get p less than 3, p less than 5. And as we know, we will take the stronger one, right? If p is greater than 5, then p will be automatically greater than 3. So we will take p is greater than 5, right? Right? Okay. And if p is less than 3, p will be automatically less than 5. So here we will take this p is less than 5. That means we have p greater than 5 means p belongs to from 5 to infinity. Now p is 5 means log 10x is 5. That means x is 10 power 5, right? That means x will be either in the interval 10 power 5 to infinity or in the interval 0 to 10 power 3. Okay. 0, why we are taking 0 to 10 power 3? Why not minus infinity to 10 power 3? Anyone? Anyone?
No.
Probably function is an
Problem is
increasing
not the
function.
same.
Function is an increasing function, not decreasing function. If you see the what
That is not the factor. So here you have
okay.
to think about the domain. We are taking log 10x, right? If I take something negative, then log 10x will not be defined, right? Domain of logarithmic function is from 0 to infinity, right? That means if I take any negative number, we can't define this first log 10x, right? That is why we will not take any negative number, okay? And x power, it is less than x power 10 power 3. That is what we got from this equation, and it is greater than 10 power 5. It is got from this equation, and it will go up to infinity. So if I take the union, this is our domain. That means this option is the correct one. Any doubt?
No.
Okay.
So it's fine for all of you, right?
Ma'am, how
ma'am.
you took p greater than 5?
Okay. So that is because the multiplication of these two numbers is greater than 0. That means both the factor will be greater than 0 or both the factor will be less than 0. It is clear up to now?
Yes, ma'am.
Yeah. Now from this we will get p is greater than 3 and p is greater than 5. And we will choose the stronger one. Okay. If p is greater than 5, then automatically it will imply that p is greater than 3, right?
Yes, ma'am.
Yeah. And if p is greater than 3, it will not necessary that p is greater than 5. So p is greater than 3, that is what we will not take. And we will take p is greater than 5 because it will automatically imply the second equation also. Okay. That is why we are taking p is greater than 5. Okay.
Okay, ma'am.
Yeah. And p is log 10x. That means log 10 is greater than 5. That means x is greater than 10 to the power 5. Okay. Any other doubt?
No, ma'am.
Yes.
Yeah.
Not in this question, ma'am, but I have a doubt in another assignment. Can I ask that?
Yeah, sure. So this question is fine for all of you, right?
Madam, I just joined. Sorry, 2 minutes. I'll just take it. This p minus 3 less than 0, comma p minus 5 less than 0. From where we got, ma'am?
Okay. So again, we have this equation. Okay. That
Yes.
if multiplication of two number is positive, that means either both are positive or both are negative.
Yes,
Right?
madam. I remember this. Last class you told us.
Yeah.
Yes.
Last class also we did the same, right?
Yes,
And
yes.
again, we will take the stronger one, right?
Yeah, that part I got it, madam.
Yeah.
Here, when it is more than 5 means it is obviously more than 3. When it
Yeah.
is less than 3 means obviously it's less than
Less
5.
than 5. So we will take this and this.
Yeah,
And
yeah.
now p is equals to log 10x. that means log 10x is greater than 5. That means x is greater than 10 to the power 5, right?
Yes.
And log 10x is less than 3 means x is less than 10 power 3, right?
Yeah, now I got, madam. This I forgot. P minus
Okay,
3 and the P minus 5 both can be negative.
Yeah.
And if it obviously have to be positive, it should be more than 0 for log function.
Yeah.
And if you put both as negative, then still it will become positive, negative to
Yes.
negative. So that point I forgot. Now you made it clear, madam. Thank you.
Okay. Yeah. Then what is the next out?
Ma'am, in assignment number 6.3, can you explain the second question?
It's taking this one.
This one.
This one?
I mean, this question, the point of the domain is clear, but I don't know how to check if the function is one-to-one, or how to check if it's strictly increasing or not.
Okay. So if it is about 1-to-1, then again I will say that the composition of two 1-1 function is 1-1 function, right? And you have to use the same logic here. That means e power x and e power minus x both are 1-1, right?
Yes, ma'am. Exponent function are always
Yes,
one-to-one.
yes. And e power x minus e power minus x will be also 1-1. We are subtracting to 1-1 function. That means this will be also 1-1. Okay. And logarithmic of this means we are basically taking the composition of logarithmic function with another 1-1 function. So the composition function will be again 1-1 function. Okay.
Sorry, ma'am. You mean that the natural exponent and e power minus x both are 1-1, because
Yeah.
exponents are always 1-1 function,
Yeah.
and because they're composition of one more 1-1 function, which is logarithms. So this whole function will be 1-to-1.
Yeah. That means
Okay.
composition of two 1-1 function is 1-1 function. So we will use this logic. Okay.
Ma'am, logarithmics are always 1-to-1 function.
Yeah. So logarithmic function is inverse of exponential function, right? And that means logarithmic function is also invertible function. Invertible means it is 1-1 and onto both, right?
Yes, ma'am.
So logarithmic function will be okay.
Yes, ma'am. Got it, ma'am.
Yeah.
And ma'am, how to check? Like if the function is 1-to-1, so it means that the function is strictly increasing, right?
No. So if it is 1-to-1, it can be increasing, it can be
Or
decreasing
decreasing.
too.
Yeah.
So if a function is increasing, then the derivative of the function will be positive. Okay. This is the result.
Ma'am,
So if f dash x is something greater than 0, that means f is increasing.
ma'am, one more thing, ma'am. The approach I remember from my high school. If you want to, like, first we used to calculate the first order derivative, then put it equal to 0 to find the critical points.
Okay, that is about minima and maxima. Like the second derivative test, it is to find the maxima and minima.
Okay. So, ma'am, can you explain this part by giving an example? Like, can you find out the derivative of the this function?
Sure. Wait. Let me write the result first, then I will find. Okay.
Okay, ma'am. Thank you, ma'am.
So this is the result. Okay. Now we have fx equals to this. So what is the derivative of log x?
1 by x.
Right. 1 over e power x minus e power minus x. Right.
Yes, ma'am.
Then we have to apply the chain rule. That means we have to again calculate the derivative of this part. Right.
Yes, ma'am.
So what is the derivative of this part? For e power x, we will get e power x again.
Yes, ma'am.
And for e power minus x, we will get minus e power minus x.
So
that
plus e power x.
Minus x. Right?
Oh, okay. Yeah. Yes, ma'am.
Right? So that means we have e power x plus e power minus x by e power x minus e power minus x. So this quantity is always positive, right?
Yes, ma'am.
And this quantity is also always positive because e power minus x is e power x is obviously greater than e power minus x, right?
Yes, ma'am. Yes, ma'am.
Right. So that means we are we are subtracting a smaller number from a larger number. So this is also positive. So both are positive. That means the total f dash x will be a positive quantity. That means our function will be an increasing function. Okay.
Okay, ma'am. Ma'am, can you scroll down to the last question?
Yeah. So it is clear for all of you?
Yes, ma'am.
It is fine, right? Okay. Yeah. Last question means this one.
Yes, ma'am.
Okay. So you just have to solve it, right? So what should be the first step? We have e power something equals to 1. We want to simplify this, right? So what should be the first step to simplify this equation?
Taking log on both sides, I guess.
Correct.
Natural log.
Correct. Natural log both sides.
Just to be clear, we used a natural log just so that the bases can be equal and we can equate the powers.
Yeah. So
Okay.
because here we have e, that is why we will take the natural log so that this can be cancelled out.
Okay, ma'am.
Okay. So this will be 1 in that case, right?
Yes, ma'am.
Like log a is equals to 1. So that is why we will take the same thing. Okay. So we will get then 4 power x minus 2 power x minus 12 equals log
0.
1 means 0, right? So again we can write it as 2 power x square minus 2 power x minus 12 equals 0, right?
Ma'am, I didn't get the this recent step. Can you please tell me that?
This line,
No, the next line.
this line. So
Yes, ma'am.
4 power x means 2 square power x, right?
Right, ma'am.
And the power can be multiplied by each other. So this will be 2x and
Okay.
this will be 2 power x whole square.
Yes, ma'am.
Okay. Then we can take this 2 power x as y. So we have the quadratic equation y square minus y minus 12 equals to 0. So what are the root of this equation now?
I guess 4 and 3, ma'am.
Okay, we can check it. Okay, yeah, we can directly break it, right? Minus 4y plus 3y minus 12 equals to 0. Then we will get y minus 4, y minus 3 equals 0, right?
Plus 3, no, madam. Y plus 3.
Oh,
Yeah,
yes, ma'am. I
correct.
will plus 3.
Correct. Okay. Yeah, thank you. Correct. Y plus 3. That means y equals to, we have 4 or minus 3, right? And what is y? 2 power x equals to 4 or 2 power x equals to minus 3. This is not possible, right?
Yeah.
Exponential function is always positive, the
Positive.
value. So this is not possible. But
2 power 2.
2 power 2. So x will be equals to 2, right?
Okay,
Fine.
got it. Yes, got it, ma'am.
This option is correct. Okay, any doubt?
No, ma'am.
Yeah, next. Anything in 6.3? No?
Ma'am, how can you find the number of solutions in a function, in the logarithmic function?
Okay, so the thing is, for that, you have to first solve the equation, what is given. Okay, then you have to check for which value you can define the function. And you have to take those values, then you can find the number of solution. Okay, if I find, yeah, this problem let us solve. Okay.
Okay, ma'am.
Here we have to find the number of solution. So first our target is to solve this equation. Okay. How can we solve this equation?
Ma'am, logarithmic property of like x squared divided by 4 divided by x minus 1.
Yeah. So first we will take ln x power 2 by 4 into x minus 1, and this is equals to 1, right?
Yes, ma'am.
Now we will take e power both sides. That means like that, right? Right?
Ma'am, why, ma'am?
So we have log e, and e power log e is equals to 1.
1.
Okay?
Okay, got it, ma'am.
Yeah. So we will basically get x squared by 4 x minus 1 equals to e, right? Right?
Yes, ma'am.
So x squared equals to 4ex minus 4e, x squared minus 4ex plus 4e equals to 0. Okay. Now what is the solution of this quadratic equation?
There can be two solutions because it is a quadratic equation.
Yeah, there can be maximum 2 solutions, but we have to check what are the solutions. We have
Ma'am,
to
one more doubt I have for the first step. Ma'am, if natural log power e will also be 1 and e raised to power natural log will also be 1, right?
Yeah.
Okay.
So it is basically coming from the inverse thing. Like we know that logarithmic and exponential functions are inverse, right? That means if compose g, one is logarithmic and one is inverse, x will be equals to g compose f of x will be equals to x, right? So if f is, suppose f is our log and g is our exponential function, okay, that means e power a power x, okay, and this is log a. So that means we have log a of a power x, okay, this is equals to x first of all, okay, that means log a x is x, okay.
Yes, ma'am.
And the second thing is, from this equation we will get a power x
Is equal to log a?
x
No, sorry, is
of
equal.
a power x, okay. See, g of log a x, right? And g is a power x, that means we will get a power log a x is equals to x, right?
Yes, ma'am, got it, ma'am.
Okay, so this is basically coming from the inverse thing.
Inverse function.
Yeah. So what will be the solution of this equation? You can use the Sridhar Acharya rule.
Which rule?
Sridhar Acharya. That means the completing the square method, minus b
Okay.
plus minus root over. So
The
4e
quadratic formula won't work here, like minus b plus minus root d divided by 2a.
yeah. By 2, right?
Yes, ma'am.
Out of the subject, because why it is called Sridhar Acharya? It is a normal
Because yeah, the
formula
rule
for
was
solving the.
calculated. Yeah,
Okay.
the calculated by him. So the rule is like by his name. Sometime we can call it Sridhar Acharya rule. Okay.
First time I'm hearing it. What we know is this is the formula for solving quadratic equation. That's all.
Yeah. So the scientist, the mathematician Sridhar Acharya calculated this. That is why.
Okay.
Yeah.
So this formula was found out in India.
Yeah.
Okay, I never knew that.
Mhm.
Okay, thanks, ma'am.
Yeah. Yeah. So we can take this 4 outside, right? Then we will get e square minus e by 2, right? That means
Yes, ma'am.
2e
2e plus or minus 2
minus
root
2e.
t square minus c by, that's all I think.
That is what we have, right?
So plus or minus is there. So e square minus e is always positive. Oh no, when it is less than one.
E squared. So e square minus e is root over e square minus e is less than e, right? 2 if
But
we can.
can okay, correct.
So root over e square is e. That means root over e square minus e is less than e, right?
Yes, ma'am.
Yes, yes.
So that means this quantity is always positive, right? Right?
Okay.
Okay.
That means we should have two number of solution. So if this is positive and this is this greater than 1? We have to check. This is what we have to check also.
So still we are not completed the solution, no, madam.
This is the solution. No?
How you are telling there are two roots?
Okay. So these are the two roots, right? 2 into e plus minus root over e
Okay.
square minus
No.
e.
Yeah, plus
So
or
we will,
minus is there. That's why you get the 2. But
yeah,
why we are checking it's more than 0?
because
We are taking log.
x, yeah. No,
Okay.
it should be more than 1 actually. X minus 1 we want to define, right?
Okay.
That means it should be more than 1. So
Okay.
is it more than 1 or not? The plus is more than 1. It is clear.
Yeah.
If okay.
Again,
So
you are
what
multiplying
about-
by 2, no?
Yeah.
Now, can't we put e? Okay, e. The arithmetic value of e cannot be used here. 2 point.
Yeah, that is what we have to do. So we have to check this value whether it is greater than 1 or not. Can you check it?
Ma'am, how can we check it, ma'am?
Calculator.
Okay, you want
Yeah.
us to use. Okay. Actually, I just graduated from the high school and we don't have a
Okay.
habit of using calculator.
Okay. But yeah, from here you can
More than it
use
will
the
be about
calculator.
5 minus 2 is about 3. Root 3 is 1. So e is 2. Obviously, it will be more, madam.
More than 1, right?
Yeah, it will be more than 1.
1. That means both the solutions of x are more than 1. So number of solution should be 2, right? So
Two.
what is the answer?
2 must be the answer.
2, right?
Yeah.
Yes, ma'am. Got it, ma'am.
Got it? Any doubt?
No, ma'am. Everything is clear, ma'am. Thank you, ma'am.
Okay. So the thing is, first, that if you have to find the number of solution, in that case, first you have to solve the equation. This is the first step. And secondly, you have to check whether for those values you can define the log or not. If you can define the log, in that case, it is fine. Okay. If in this case, suppose if one of this root were less than 1, in that case, we cannot define the second log, right? Log of x minus 1, right?
Yes, ma'am.
But that we need both the roots should be greater than n, and we found it that both the root are greater than 1. That means both the root can be the solution of this equation. Okay, like this we have to always find the number of solution of some given equation. Okay, any doubt?
No, ma'am. Ma'am, whenever I watch the lecture, ma'am, I'm usually not able to solve the assignments. Is it normal or I'm not able to grasp like?
No, it's normal. It's normal. First time you may find some difficulty in it. No problem in it.
Okay. So I thought like I was normal or something. I thought
First
that.
time
No.
you do it in 1x speed. Next time you do it in 1.25
Yes.
or 1.5 speed.
Yeah,
3 times you have to watch.
gradually you have to increase your speed. The thing is, more you will practice, more you will get you will be more comfortable with it, and like you have to apply the formulas basically, right? That is why you need to practice those things.
Yes, ma'am.
Yeah.
Thank you, ma'am.
Yeah, welcome. So yeah, what are the next out? Anything in 6.4? No? 6.5?
So what I can infer is nobody has tried these things. Up to 4 only we have 3 or 4 only we have tried.
Okay.
Because I also did up to 3 only, madam. I was not able to do more than that.
Okay.
Tomorrow
Then I will pick some problem
please,
which
madam.
you may face difficulty with. So I will solve them.
Yeah, ma'am. Easy to moderate.
Yeah.
Yeah, easy to hard.
Okay, 2 and 3 we will solve. Okay.
Okay.
So we can try it together. So yeah, what can be the first step?
Here, I think we have to use change of base rule and make it into ln.
Correct. So we can write it as 1 by log 2x plus 3 we can take, then we will have log y2, then log
3
2y.
because 2 power 3, madam. Okay.
Yeah. Okay. We can actually write it as, no, it's fine. Okay, so no, not in this form.
Ah. No,
We
first
can directly write it log
log x.
by log x maybe, right?
Yes. Then log 8 by log 8 by log x.
So 0.
So
Then
log
we can multiply, cross multiply them, right?
yes, madam.
So log 2
Log y plus log 8 log x.
3 log 2
Okay.
log
Equal
8
to 0.
0. Then we can take log 2 as common, right?
Yes, madam.
So we will get
Log y
log
plus
plus log x
3.
cube,
Okay, log x cube.
right? We know that log 2 is not equals to 0, so we can multiply it, right?
Yes.
So we will get log y x cube is equals to 0, right?
Yes.
That is equals to
X
log
cube.
1.
Yes.
That means y
Yes.
x cube will be equals to 1, right? This one.
Fourth one.
Yeah, and also that means the second option is incorrect, and for yeah, so first and third option we have to check whether it is satisfying this equation or not, right?
Yeah. Yes. So we directly log y, we have to put 1 by 8 and x2 cube. So 8 by 8 is
This
1. So answer is correct. First one. Yes,
and
madam.
this is incorrect. So first and last option is correct, right? Can you check the answer whether these are the correct or not? Okay, I can also do that. Yeah, so these two are the correct options. Okay, easy, right?
First option we would have directly put and found out also. No,
Yeah,
madam. Like
yeah,
log,
right.
I mean, if time permits, if a lot of time is log x means log 2 base 2 and
That
log
means
8.
1.
Yeah, that will be 1. And
Yeah.
log 8 base 1 by 8. 1 by 8, how would you change? It will be minus to the power of.
So see, if I have log 1 by 8 of 8, we can
Yes.
write it as log 8 power minus 1, 8, right? This minus we can take it here. Minus 1. Log 8, 8. This will be 1. So
1
this will be equals to minus.
minus 1.
Okay.
So this part, can you tell me, madam? Like log 1/8 equal
This one?
to. Yeah, that part.
Okay. So it is a formula. If you have a power some n b, then it will be 1 over m log ab. And how can we prove it? Simple. Using change of basis rule. So you can write, if I have log a power m b, we can write it as 1 over log b a power m, right? Then we can take this m here. So it will be 1 over m into
No,
log.
why it has come to the denominator, that a power m? I mean, from base, how
We
it has
have
become
base as b, right? We have base as b and power as m, right? Change of basis rule, right?
okay. B, you are taking it as for b. So for numerator will be
Yeah.
log b is 1.
Yeah.
And here it will be log a, yeah, whichever is power was there, it will become
Yeah.
the base. And okay, now.
Okay. Then we
Fast, you
can.
are fast.
No.
Okay.
Yeah.
Sorry,
So
sorry.
this is
Go ahead.
basically log BB. Okay, is it
Yes,
fine
yes.
now?
Yeah, I got now.
So this M we can take here, right?
Because it is in power, it will come outside.
Yeah. Then we will get M log BA, right?
Yes.
So 1 by M, take it separately. Then you can again write it as log AB similarly.
Yes.
Okay, fine. We
Okay.
proved the formula. So this is one of the formula. This is consequences of the main formulas. Okay. Any doubt in this portion?
So, correct. Week
Any-
actually week 5 is little bit tougher than last week 1 to 4 and maybe little
Yeah,
bit.
the thing is in week 5 and week 6, you have to apply the formulas actually. You have to play with the
Concepts.
formulas. That's
Yeah.
the thing. That is why you need practice and all.
Okay.
Week,
And one should be very clear on the concepts.
yeah. And also you must be very clever while applying the formulas. Like when
Formulas.
we should apply which formula, you should be very clear about it, right?
Yeah, sure, madam. Because base log 1 by 8 or log 8 base 1 by 8, I could not visualize this at all. The verb you explained. After you explained, we are able to visualize. But before that,
Yeah.
1/8, how 8 is coming, what we have to, because log base 2 is easy.
Yeah.
Second part was little bit tough. We have, as you told, practice is main thing, madam. Yeah, right.
Yes. Basically, you have to practice and you have to connect it like from one formula to another formula, you can go logically. So you have to try it. Like, how can we prove one formula using another formula? Okay, and it will be really helpful. Oh, okay. Yeah.
Madam, one general question. When have you signed off, madam? When is the results coming? This one?
About the date, I'm not very sure, but it should come before 1 or 2 weeks.
Oh.
Yeah, it will not take more than 2
And
weeks.
normally it will come within a week. By Saturday it should come.
So it should not take more than 1 week from now.
Okay.
Yeah.
Thank you.
Okay, so this is another question, some analyzation we have to do. We can do it. Okay, so this question is bit about, like, you have to think about this question. So we have the function x minus box x. So you know what is box x or the greatest integer function? You know it, right?
The greatest integer, madam, whatever, if it's 3.4 means you have to take 3.
3.
I mean, 4.
That means the greatest, no, 3. So
3,
the greatest integer which is less than the number.
Number.
So box of 3.4 is 3.
3.
Similarly, box of any integer, suppose 5 is that integer only. Okay. Box of 4.2 is what?
4.
4, right? That is how we have to do it. Okay. So this is the definition of box of x. And x minus box of x means we will take the rational part. Okay, that means the part after the point. Okay,
Yes.
so it can be denoted by x within the curly bracket. Okay, so if I take x equals to 3.4, what will be the value of this?
0.4.
0.4. Yeah. So the thing is, the value of this quantity will always lie within 0 to 1. Right? That means, like, if we can take any x, if I take integer, like if x belongs to integer, then what will be the quantity?
0.
Can I take any integer then? If I want to, like, suppose define the domain of this, domain of the function. So log 0 is defined or not? No,
Not
right?
defined.
Yeah.
So integers you cannot take.
Correct. So we will not take any integer point. Okay. That means the domain is real number minus
integer.
So accept any integer point, the value will be from 0 to 1, right? So there we don't have any problem, right? That means the domain will be r minus z. It is clear, right?
Yes, ma'am.
Yeah. So the domain is infinite. First option is correct, right? This set is a infinite set, right? The cardinality of the set is infinite. So R minus domain
So
will be
capital,
Z.
madam, sorry, madam. Capital D means domain, ma'am, always.
Domain. Yeah, yes.
Okay.
So D is the domain. And R minus Z is the domain here. It is an infinite set, right? That means the first option is correct, right?
Okay.
Yeah. And R minus D means integers, right?
Yes.
That means it is again an infinite set. The second option is also correct.
Correct.
Yeah. Now, the graph of f have an infinite number of vertical asymptotes. So what do you think about it? Whether it will be correct or not?
Now, every integer, it will be an asymptote.
Correct. Very good. So the thing is, whenever, suppose this is 1, this is 2. So in this interval, if this is 3. So every time we will get this type of thing, right? Negative asymptote we will get like this type of thing at every integer, right? Like whenever x will be tending to some integer point n, then x minus box x will be tending to 0, right? Will be tending to 0, right?
Yes.
So for each this type of case, the function will be tending to minus infinity, right?
Yes, madam.
F of x will be tending to minus infinity. That means each integer will be a vertical asymptote. That means the number of vertical asymptote is infinite, right? So the third option is also correct.
And what will be the positive when it will be positive, when a y side? What will be the graph between 1 and 2?
1 and 2. Like it will be like that always.
Again, it will not meet. Whether it will meet
No.
somewhere.
No. It will not meet. So it will be a periodic type of function. Okay.
Again, that will be again a positive side asymptote only, no, madam, before 2.
No, because in the positive side, it is not infinite. It is not going to infinity. It is restricted up to this.
So you will have a solid dot.
Yeah, because always we know that the original graph of logarithmic function from 0 to 1, this will repeat all the time in each interval. Okay.
So, okay. No, I am not
That
able
means,
to. We can visualize it.
okay. So
At
if
2,
I take y
before
equals
2,
to
2
x
minus and 2
minus,
plus, what happens? I'm just seeing.
yeah, okay. I'm just saying that. So if I take y equals to this quantity, so y will always vary from 0 to 1, right?
Yes, ma'am.
That means, suppose if I take one interval in like 1 to 2, okay?
Okay,
So in this
okay.
interval,
Now y cannot go more than 1 actually.
more than 1. That
Okay.
means this quantity cannot go more than 1, right? That
Okay.
means this will, we know that logarithmic 1 is 0. So we will, okay, logarithmic 1 is 0, right? That means we will get from this point to like that, okay?
Yeah.
That means the graph of the logarithmic 1, like the graph of the logarithmic function from 0 to 1, it will basically repeat in each interval.
Okay, correct.
Okay.
Yes, madam. I could
Got
get
it?
that.
Yeah. What about the next one? Is it invertible on D?
No, it cannot be invertible, madam.
Why?
No, because it is not at integer it is not defined, no. So the range.
No. Integers, this is not the reason. I mean, integers is not defined. That is what we are excluding the integer from our domain.
Oh, domain itself we are included. Okay.
Yeah. So, any other reason why it will not be invertible? Any other reason?
Okay.
Like, look at the graph. It is really easy. You can do it. I know. The graph.
The invertible is XY graph. It should be mirror image of XY. That
Don't think in that way.
that's
Invertible means what? Bijective, right?
bijective. It should be
1
both
1
range.
1 1 and on 2.
Yeah.
Is it 1 1?
It is not one because it is not 1 1, ma'am.
Right? Horizontal line test.
Horizontal line test, number of points will be there.
Infinity number of points will be
Points.
there, right?
Yes.
So if the function is not 1 1, hence it is not invertible. Right?
Invertible.
And the range is not R, right? The range is from 0 to minus infinity, like minus infinity to 0, right? Right? Domain, always we will get 0 to 1. So when we will go towards 1, we will get 0. And when we will go towards 0, we will get minus infinity, right? So we will, in the domain, we will get always 0 to 1, right? Right?
Yes, ma'am. Yes, ma'am.
Yeah. So if x is going to 1, that means f will be going to 0. And if x is going to 0, then f is going to minus infinity. So the domain, the range will be a minus infinity to 0, right? Clear?
Yes.
Okay, so this was a nice question. This is what you can do, I guess. What about activity 6.6? The first question you can do, right? Simply, you just take 5 front and take log x equals some quantity and solve the quadratic equation. Okay?
Yeah.
Okay. The second question, you just solve and let me know the answer. Use the formula what I just told. Log a power mb equals 1 by m log ab. So this will be 1/3 log 2 x cube minus 1 equals log 2 x minus 1, right? Right? This 3 we can take here, then here. So this will be log 2 x cube minus 1 equals log 2 x minus 1 whole cube, right? Then we can cancel the log. So we will get x cube minus 1 equals x minus 1 whole cube. Now solve the equation and let me know the root of the equation. X minus 1 whole cube formula we know, right? X cube minus 3x square plus 3x minus 1. So minus this 2 will be cancelled out and we will get, if I take 3x as common, then we'll get minus 3x as common. So x minus 1 equals 0. So either x will be equals to 0 or x will be equals to 1. Then what will be the number of solution?
X cube minus 1 will be 0, so log 0 you cannot have. So there can be only one solution, madam.
Think it once again.
X minus 1.
Just check the equation first. If you put 0 instead of x, then what we will get?
Minus 1 will be there, then 0. Okay, log base at x cube 1. 0 minus 1 is minus 1. So negative, it is not defined.
Yes.
And even 1, if you put, it will be 0. Log 0 also is not there, no, madam?
Correct.
So 0 will be the answer.
Yeah, number of solution is 0. Okay. Clear? Let us check the answer. Number of solution is 0. Clear? Because no solution is satisfying the equation. We can't define the equation even. Okay. Any doubt? Any doubt?
No, no, no.
No, ma'am.
Okay,
ऐसे ही डाल देते.
got it, right? Okay,
General
so
takeaway for we have been finding out here one basic thing is find out the roots, put the
yeah,
roots back in the original
equation.
problem
Yeah,
equation, and find out whether it is within the domain or not.
domain or not. Yeah, correct.
Yeah,
Very good.
that is more important.
Yeah.
Okay.
That's the thing we have to always do to find the number of solution. Okay. Yeah. Any other doubt do you have? I guess I have completed almost all the needed questions. Now, if you have any other doubt, you just ask.
Nothing, madam, from my side because I have not done. So maybe tomorrow we'll do it, and next class any doubt is there we'll ask.
Sure.
Tomorrow is the last date anyhow. That's okay. But
Yeah,
we'll
yeah.
have other sessions, no future sessions.
Sure. You can
This
ask.
course is there.
Yeah. Revision sessions are there. Also, you can ask in other sessions.
This time revision sessions will be earlier or similar to the last week only, madam. Last
Yeah,
days.
this will be similar to the last week, maybe like before the quiz. Someday before the quiz.
Okay. Okay. Okay.
Hmm.
Okay,
Like
madam.
before the revision session, you should check all the problem once so that you can ask the final doubts in the revision sessions, right?
Okay, madam.
Yeah.
Tomorrow week 8 also will be released. And 7th
Yeah.
week 9, 14th week 10, okay, last. Maybe 13,
Yes.
14, 12, 13, 14 we'll have the revision session for this.
Yeah.
Okay, madam.
First, we will cover the weeks. I mean, the deadline we have to follow, right? Or
Yeah.
so we will follow the deadline. Then we will take the revision sessions.
Okay.
Okay. Yeah. So if you
Thank
have
you,
any
madam.
other doubt, then you can ask. Otherwise, we can. Yeah.
Almost we are only 5 students here.
Okay. I have not seen the number of students.
Yeah.
Okay. Some. Okay. So if you don't have any doubt, we can end.
We'll have early dinner. Okay, madam. Thank you. Nice
Yeah.
session. Even though I was a little bit late, but I still enjoyed the last half an hour, 45 minutes. Thank you, madam. Good night.
Yeah. Good night. Good night, all of you. Prince, are you there? Okay, let me check. You wrote something.
End of session.
Yeah. I am ended the session. Okay, Prince, I will discuss your problem. Then I will let you know. Okay. Okay. We can maybe end the session then. Yeah, Prince, I have seen your message. I will discuss about it and let you know. Okay. Sure. Okay. So I'm ending the session. Fine. Yeah.
Good night, ma'am.